501. Continuing activity 1, geometric mean. Let's talk about the worked example, but you should also go back and find page 498 and fill out what you can on page 498 before we go. You can identify the geometric mean, highlight it, to help you solve math problems, geometry situations. So in this worked example, I have all 3 highlight colors, by the way. I think you're going to need them. Okay. The geometric mean is the altitude length of 12. And when we have that value, it's going to be located twice in the proportion. We have it located here and here. And then they do a little reduction, or they do some information. So they set up that this 8 is the short leg of ACD. So when they make 8 over 12 as that fraction, they're using the altitude leg right triangle geometric mean like structure. In the other triangle, the 12 and the x are the 2 legs. But in this one, 12 is the short leg of this triangle. And x is the long leg, so it goes on the bottom. Just like over here, 12 was the long leg, so 12 went on the bottom. So it's like 12 is being used in 2 locations because it's the line that is sandwiched by 2 similar triangles. Now you got to solve for x. And, I don't know, cross multiply or multiply both sides by the denominators, or reduce the fraction first, or flip, and then, that's actually a good technique. I'm going to do that right here. I'm going to show you another technique. You know, if we flip both of these fractions, then 2/3, its reciprocal is 3 over 2, and the reciprocal of 12 over x is x over 12. By flipping both those fractions, we maintain equality. There's some multiplication and division that's happening, but reciprocal of 2 fractions, if 2 fractions are equal in proportion, then the reciprocals are also in proportion, provided x is not 0. And solving for x now, all we have to do is multiply both sides by 12. It is 12 over 1, but and you're going to put the 12 in the top of the fraction, not on the bottom. So then 12 and 12 reduce, and then 12 times 3 over 2 is 18. Therefore, we now have information. We have the length of x is 18 units. Let's practice this twice. In question 2, we have a triangle, and it's given in this arrangement. And we have some hypotenuses that are not known, and we have some legs that are not known. We have an altitude that's not known. I'm going to start there. I'm going to start there with the altitude. I'm going to start by going like this. X as the altitude of that triangle needs to be used twice in proportions. So I'm going to set it up as x on the top and x on the bottom. And in the first one, I'm going to go 5 is the short leg, x is the long leg. So x on the bottom, 5 on the top. Then I'm going to go x is the short leg and 10 is the long leg. And I'm going to solve for x to figure out x's value. By cross multiply, we wind up with x squared equals 50. And just like we've talked about this entire section of videos, lesson 4 videos, when you square roots, you should have a plus minus answer, but this is on a triangle, and a negative distance doesn't mean, well, anything. What is a negative distance, right? How far away are we right now? Well, am I now negative? It's always a positive distance. Hey Siri, what's the square root of 50?
The square root of 50 is approximately 7.071.
Okay, so it's approximately that long. Square root of 50 is a better answer. But if you needed to know how much money that was amounting to, square root of 50 is about $7.07. We still have to find y, and we have to find z. And what I notice is that z is I'm going to do green. Z is the hypotenuse of its little triangle, and y is the hypotenuse of its bigger triangle. Both of them use an x, and they use a 10, and they use a 5. Oh, we could do Pythagorean theorem right now too, but I think I want to stick with proportions. I could say we could use Pythagorean theorem because we now have 2 sides of a right triangle. Do the Pythagorean theorem, you'll find the third. We have 2 sides of this right triangle. Use the Pythagorean theorem to find the third. But that is math that is good to know. I'm still trying to drive home the point of geometric mean. We could set up a proportion, so I'm going to get that lined up. And I want y to be one of the proportions. If I do y to 10, that's the hypotenuse to the long leg. And then over here, ooh, I don't like that. Oh, okay, wait, would that work? Would that work? This is how this will work. So we have long leg to the hypotenuse, so that's, I'm gonna go 15. For the long side, then y is gonna be the hypotenuse of the medium side, and its leg will be 10. Process that for a minute here for a second. In this problem, y is the leg of the large triangle, and 15 is the hypotenuse. In this proportion of this triangle, y is the hypotenuse and 10 is the leg. It's all about where you put your letter and how you're perceiving the triangle. For now, until you practice this a million times, trust but verify. We have 15 here. We have 15 times 10. And it's going to equal y squared because we're going to multiply both sides by y. And we're going to multiply both sides by 10. So we no longer have a fraction. We have 150 equals y squared. To cancel the y squared, we're going to square roots. And you know, that bell is for me. It's not for you. Pay no attention. You're not dismissed. The y can switch to the other side. We have y is equal to the square root of 150, which is approximately. Hey Siri, what's the square root of 150?
The square root of 150 is approximately 12.2474.
Okay. We have one last value to find, and that's z. Again, we could use Pythagorean theorem to find the value of z, or what we could do is we could set up proportions. This is about setting up the proportions and solving. Before I begin, I need to think carefully about what I'm observing. I observe that z is a hypotenuse of the little triangle. I observe that 5 is the little leg of this little triangle. So if I do z to 5, that would be z, the hypotenuse, divided by 5, the leg. And then in the big triangle, z is now the little leg of the big triangle. So I can put z on the bottom. And the hypotenuse would be all of this. It'd be 10 plus 5. So I thought carefully about how z is a part of the small triangle as the hypotenuse, and then how z is a part of the big triangle as the little leg. And if I happen to have the numbers like 5 is the little leg and 15 is the hypotenuse of their triangles, then I can set up a proportion. Z is the geometric mean, and I can solve for z. Multiply both sides by 5. Multiply both sides by z. We wind up with z squared equals, 5 times 15 is 75. Square root, z is approximately equal. Hey Siri, what's the square root of 75? Try it again. Hey Siri, what's the square root of 75?
It's approximately 8.6602.
Okay, we have our three numbers. Now there are exact answers here. I'm gonna do like a short video on how to do the exact answers here, maybe a 1-minuter that you need to watch. Now let's do the last one. Solve for the length of the bridge in the getting started using the geometric mean. So bring out page 498. And we have the diagram here, and now we have all the information that we need to actually find the length of x. So I'm gonna highlight it because we should make it visible. And I'm highlighting the altitude. It didn't really show up, but that's all right. I'm gonna highlight this leg as something to focus on. And then because the bridge is already orange, I'm just gonna highlight the entire bridge orange. I have those colors ready to go. But I gotta think carefully about my fraction of sides. X is the long leg, and 130 is the short leg of that triangle. 130 is the long leg. Is 130 the long leg? That's a little bit deceiving right here. Like this triangle, there's like a rotation, right? That's the thing that I've noticed. There's a rotation of the triangles. Like this side should be similar to this one, depending on which triangle that you position it. So letters. Letters is definitely the case. I'm going to rewrite the proportions from page 499 into P, Q, R, and S, and then pick the P, Q, R, S that matches. So I have triangle P, Q, S. Let me bring this like this. Kind of works, sorry. Is similar to, I'm putting the S 90-degree angle at the end, 90 degrees at the end, and the bigger angle at the front. So then in the small triangle, it's PQS. In the medium triangle, it's QRS. And then in the biggest triangle, PRQ. I'm trying to just keep the letters consistent so that the last letter is always on the 90-degree angle. S is on the 90, S is on the 90, and Q is on the 90 for their respective triangles. Which means I can now make my fractions. I happen to know PS is 135. So those two. I happen to know QS is 130. I happen to know RS is X and QS. So I have my information now. I have my information now because I need to write down similar things. So I have PS, QS, and then I have QS, RS, and RS was X. So RS, QS. Here's my geometric mean setup, where in the geometric mean, there is a number that's used twice. Maybe it's unknown, maybe it is known, but it's used in two locations. Now I put in the numbers I know. I know PS is 135. I know QS is 130. I know that 130 is in two locations, and I know that the length of the bridge, RS, is unknown. Solve for X. I'm going to use the reciprocal method first, which means this would be the same as 130 over 135 equal to X over 130. I'm going to multiply both sides by 130 to reduce there, to multiply here. Now I need to know, hey Siri, what's 130 squared divided by 135?
The answer is approximately 125.1851.
Feet equals X. Thank you for watching this video. I will see you in the next episode.